Hello guys, my name is Jace and welcome to the Big Brainerds. So in this video, I am going to take you through video 2 of organic chemistry. Remember in video 1, we introduced organic chemistry where we talked of the terminologies that you need to know in organic chemistry and the nomenclature and everything else. So in this video, we're going to look at now the homologous series, and specifically this is going to be alkanes. So this is part A of alkanes, and there will be also part B of alkanes. Don't forget to check out the video. All right, so with that being said, let's jump into it. So what are alkanes? Alkanes are simply saturated hydrocarbons. Why do we call them saturated hydrocarbons? This is because they contain single carbon to carbon bonds. Okay, so why they contain single to carbon bonds? So here in this case, hence they cannot take part in any additional reaction. Right, they cannot take part in this reaction. So what is an additional reaction? To make you understand, let me just have an example of methane. So methane is a 1 carbon alkane. So as you can see here, I'm drawing its structure. So this is the structure of methane. So methane has got only 1 carbon and it has 4 hydrogens. So in this case, remember that the combining power of carbon is 4, right? So since the combining power of carbon is 4, as you can see, this structure is filled up, meaning that it cannot allow any other element to be added to this compound, to this entire compound. All right, so this carbon is filled up. That is why hence we call it saturated hydrocarbon. All right, so that is why we call alkanes saturated hydrocarbons, because they contain single carbon to carbon bonds and all their compounds are filled, all their bonds are filled up. Right, then another thing is that they have a general formula of CnH2n, like that, where N stands for the number of carbons, which can be 1, 2, 3, 4, 5, etc., etc. It can go as far as 50. All right, so using this general formula, you can use this general formula to actually derive other homologues of alkanes. So let's use this general formula to derive some homologues of alkanes. So let's try to derive a 2 carbon alkane compound. So a 2 carbon alkane compound will put C2H2 there, 2 in the bracket, plus 2, using this same general formula. So C2, to compute this, we have C2H 2 by 2, which is 4, 4 plus 2, which is 6. So this is what, then remember that we said when naming organic compounds, we used the rules where we were using the prefixes coming from the number of carbons. So here the number of carbons is 2, so meaning that our prefix will be eth, right? Eth. Then our suffix will be what? Our suffix will come from the homologous family, which is alkanes. So in this case, our suffix will come from the homologous family alkanes, and in this case, it will end with what? With what suffix? It will end with n. So meaning that our compound here is ethane. That's what we've derived here. So go ahead and maybe pause this video and try to derive using this formula, this general formula, to derive for a 3 carbon compound, 4 carbon compound. So 3 carbon compound propane, 4 carbon compound butane, 5 carbon compound pentane, 6 carbon compound hexane, 7 carbon compound heptane. So try to derive those and see how conversant you are with this general formula. And in that case, also try to draw. So here I'll just try to draw for ethane, to draw the molecular structure of ethane. So as you can see, it has 2 carbons, 6 hydrogens, and one property you shouldn't forget is that it has a single carbon to carbon bond. It does not have a double bond or triple bond, but a single carbon to carbon bond. So let's try to draw that. So we have carbon to carbon, then it has 6 hydrogens. So since it has 6 hydrogens, so let's draw 1, 2, 3, like that. Okay, so this carbon here is filled up. Okay, this carbon is filled up because why is it filled up? It has all the 4 bonds it requires. Its valency is filled up, all the electrons are filled up. Then let's draw the other hydrogens for this one. So we have 1, 2, 3, like that. So all together we have 1, 2, 3, 4, 5, 6, which qualifies our structure because it matches with our formula, like that. So in that manner, then I've already mentioned to say they end with the suffix what? ane. So if you have 1 carbon methane, 2 carbons ethane, 3 carbons propane, in that order. All right, with that being said, let's proceed. Okay, so let's look at preparation of alkanes. So when we look at preparation of alkanes, in short, how can you prepare alkanes in the lab? So the first thing is, let's look at the preparation of methane gas. So how you prepare methane gas in the lab is simply you set up your apparatus like this, as you can see. So you have your Bunsen burner, you have your boiling tube, you have your delivery tube, sorry, and you have your trough like that. You have your inverted gas jar. So remember that methane gas is simply less dense than water. So when you have water there, methane gas will ascend, and it will be collected up there on top of water. Okay, so what do you react to prepare methane gas? So what you react to prepare methane gas is simply sodium acetate. So what is sodium acetate? Sodium acetate is, the other name is simply anhydrous sodium ethanoate. So if you hear anhydrous sodium ethanoate or sodium acetate, it's simply the same thing. Then you also react it, you mix it with soda lime. Soda lime is just simply sodium hydroxide. I'll show you the reaction. So you mix it and put it in your boiling tube, and you heat the mixture. When you heat the mixture, the reaction will take place, and what will happen is that methane gas will be collected up there in this inverted gas jar. Alright, so let's look at the reaction. The reaction, this is the reaction here: sodium acetate, sodium plus sodium hydroxide to do what? To produce methane gas and sodium carbonate. Alright, so this is the chemical equation for this reaction. Okay, so this is how you prepare methane gas. Then another thing that we should look, or that we're going to look at, is simply some of the characteristics of methane gas. So the characteristics of methane gas is that it is colorless. Then it does not have color. Then it is odorless, meaning that it does not have any smell. Okay, then it is a natural gas. So it is a natural gas because it is produced by decaying matter. So when you have decaying matter, such as dead plants, dead animals, when they are decomposing and breaking down, their components are breaking down, they release methane gas into the atmosphere. All right, so that is the preparation of methane gas, which is an alkane. Then next let's look at the preparation of ethane. Okay, so let's look at the preparation of ethane. All right, so ethane gas, how you prepare ethane gas? It's simply by catalytic hydrogenation. So you prepare ethane gas by catalytic hydrogenation. All right, so catalytic meaning that there is involvement of a catalyst. Hydrogenation meaning that you add hydrogen gas to something. Okay, so in this case, to prepare ethane gas, this is what we have. So I know we haven't yet looked at alkenes, but in this case, how you prepare ethane gas, you will get a sample of an alkene. In this case, you get ethene. Alkenes are also known as unsaturated hydrocarbons. Not saturated, but unsaturated. So they are called unsaturated because they can take part in additional reaction. So in this case, how will they take part in additional reaction? This double bond that you can see here, it will break, and when it breaks, it can accommodate other compounds or elements. So in this case, in this reaction, to prepare ethane gas, what will happen is that hydrogen gas, because it is hydrogenation, so we are adding hydrogen gas, so it will break this carbon compound and we will add these 2 hydrogens. So remember, we had 4 hydrogens at first in ethene. Then when this hydrogen bond breaks, what will happen is that we will accommodate these 2 hydrogen gases, and there we have it. We have ethane gas. Then what are the conditions for this reaction to take place? The conditions are that you must have a catalyst, which is nickel metal. because remember it is catalytic. Then another condition is that the temperature should be at 300 degrees Celsius. So this is the reaction, that's the chemical equation. These are the conditions that I've already mentioned. Then another thing is that ethane gas can also be produced via catalytic cracking. So we are going to look at catalytic cracking in part B of alkanes. Okay, then let's look at some of the properties of alkanes. So the properties of alkanes are, we have physical properties, and we also have chemical properties. So under physical properties, the first thing is that, remember, like we had looked at in video 1, we looked at properties of homologous families. So here, remember we said physical properties, they vary in physical states. So their physical states vary at room temperature, as lower members are gases and higher members are solids. Remember, as you are increasing the number of carbons, even their physical states also changes. Then number 2, the melting and boiling points and their densities increases with increasing number of carbons as well. Right? So in that case, then we continue. Then the chemical properties, we have combustion. So chemical properties, as you know from chemical reactions, so we have combustion. So alkanes can take part in combustion, and it can take part in 3 kinds of combustion. It can take part in complete combustion and incomplete combustion. So the first one is that in complete combustion, alkanes react with oxygen to produce carbon dioxide and water. So to show that, let me just try to write the chemical equation. So I'll just give an example of methane gas. So methane gas here will react with oxygen to produce what? Carbon dioxide. So it will produce carbon dioxide there, and water. Okay, so this is incomplete combustion. So complete combustion meaning that there is enough supply of oxygen. Then the next property is that in incomplete combustion, alkanes react with insufficient oxygen supply. This is the keyword. So in insufficient oxygen supply, meaning that there is less oxygen supply. So I'll give another example of methane reacting with oxygen gas. Then in this case, since the oxygen gas is less, so meaning that it's insufficient, so meaning that it will only produce what? Carbon monoxide, not carbon dioxide, plus water. Okay, then another property is that in very limited oxygen supply, alkanes react to form carbon only and water. So in this case, again, I'll give an example of methane gas reacting with oxygen gas, but in this case, instead of producing carbon dioxide or carbon monoxide, it only produces carbon and what? And water. Okay, and water. Don't mind my handwriting. Then whenever you are writing a chemical equation, don't forget to balance. Okay, always balance your chemical equation, very important. It will earn you marks. All right, okay, so we continue. Then another property that we are going to look at, chemical property, is substitution reaction. So substitution is just simply a reaction in which one atom or group of atoms in a molecule is replaced by another. So substitution is simply means to replace. So alkanes undergo substitution reaction with halogens in the presence of what? Ultraviolet light. So do not forget this. So this is the condition for alkanes to actually undergo substitution reaction. It's in the presence of ultraviolet light. An example is simply halogenation of methane. So when methane can actually react with chlorine gas in the presence of sunlight. Remember halogens on the periodic table, so chlorine gas is a halogen. So it will react with methane in the presence of sunlight to form chloromethane and hydrogen chloride. This is the chemical equation. So this is methane plus chlorine gas to produce chloromethane and what? And hydrogen chloride here, which is a gas, right? And this is the reaction, methane there and everything. Then these are the conditions. The conditions are that the temperature should be at 200 degrees Celsius, and the catalyst is simply sunlight, which is ultraviolet light. Okay, so thank you very much. I think this is where we end our video. Do not forget to share, like, and subscribe, and also please indicate in the comment section of what you would want us to cover on our Big Brain Busters channel. Do not also forget to check out our other videos. Thank you very much. Shalom, shalom.